In the previous video, we talked about heat engines. In this video, let's now take a look at the concept of the refrigerator. Basically, a refrigerator is a heat engine operating in reverse. You'll recall that a heat engine takes heat from a hot reservoir. So heat QH is taken from hot reservoir and work is performed, and wasted energy or the extra energy is dumped to the cold reservoir. You have QC being dumped to the cold reservoir. So QH is taken from the hot reservoir, work is done, and then QC is dumped on the cold reservoir. The refrigerator does the opposite, or the reverse is done with the refrigerator. Input work is required by the refrigerator so that it is able to take heat QC from the cold reservoir and then dump QH to the hot reservoir. Basically, a heat engine operating in reverse. So again, mechanical work input is required for the refrigerator to take heat QC from the cold reservoir and then dump heat QH to the hot reservoir. Which means QH is basically work plus QC. The input work plus the heat QC taken from the cold reservoir. Heat pump and air conditioner are basically other types of refrigerators. The best refrigeration cycle is one that removes the greatest amount of heat, QC, for the least expenditure of work, which means the relevant ratio is comprised of QC and work. This ratio is called the coefficient of performance, and the variable is K. K is equal to absolute value of QC divided by absolute value of W. Absolute value of heat QC divided by absolute value of work W. Describing basically how well the refrigerator is able to take the work done to take QC from the hot reservoir. Work is still equal to Q. The refrigerator is still basically a heat engine, albeit one that is operating in reverse. So it's still a cyclic process. A cyclic process is still involved. Therefore, W is still equal to Q. And Q is equal to QH plus QC, or absolute value of QH minus absolute value of QC, which means work, absolute value of work is just equal to absolute value of QH minus absolute value of QC. So we have another equation for K. K is equal to absolute value of QC divided by absolute value of QH minus absolute value of QC. For air conditioners, the quantities of greatest practical importance is or are the rate of heat removal H, how fast the air conditioner is able to remove heat from the room, and the power input P to the compressor, so the power rating of the refrigerator. So K now is equal to H divided by P. For a more complete picture of a refrigerator, you might want to take a look at the concepts of the energy efficiency rating or the EER, as well as the concept of the heat pump. So consider this as reading assignment. And that's it for now. In the next video, we'll take a look at the concept of the second law of thermodynamics itself. So thank you for watching.